I am Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. So today's topic is C tokens. So last video lecture we have discussed some of the C tokens. So remaining C tokens like special characters, strings and operators. So those we are going to discuss today. So C tokens, let us see what are C tokens first. So as we have seen that these are the basic building blocks. So the smallest unit in a program or statement is called as token. So compiler identifies them as tokens. Next, coming to the types of C tokens which are supported by C programming language are keywords, identifiers, constants, operators, special characters and strings. So out of all this we have discussed about keywords, then identifiers and constants. So in this video lecture we will discuss about operators, special characters and strings. So in that first one is operators. What are operators? So operators are nothing but symbols. So these are special kind of symbols which are used to perform logical or mathematical operations on data or value, you can say, or operand. Operand is nothing but variable. So these are special kind of symbols which perform logical or mathematical operations on value or variables. So data items on which the operators are applied, they are known as operators. So for example, if we want to perform some operation, if we want to perform mathematical operation like 3 plus 5, that is addition if we have to do for 3 and 5, then this is the operator which we are using. So here these 3 and 5, these are called as operands. So the data items or the variables on which the operators are applied. So here the operator, this is the operator. So it is a special symbol which is used to perform mathematical or logical operation. So these are the operands and this one is the operator here. And together it is called as expression. Together it is called as expression. So this is the operand and this one is the operator. So C language supports various types of operators depending upon the number of operands. So depending upon this, we have three types of operators, that are unary operator, binary operator and ternary operator. So first one, unary operator. So the operator works on, this type of operator, it works on single operand or variable. So for example, if we have a variable x, so if only one variable is involved, or so the operator which operate, unary operator, it works on single operand. So in unary operator, we have different types of operators. So that we'll see. Next, binary operator. So binary operator, as you, from the name itself, we can say that it works on two operands or variables. And ternary operator is, it requires three operands or variables. So it works on more than two operands or variables. First one, unary operator. So in unary operator, so these are the different operators. Increment operator we have, decrement operator. Apart from that, we have one more, size of operator, then address of operator, size of operator, address of operator. So these are the operators, and then minus operator, unary minus. Next, in binary operators, so these are the different operators which are available, like arithmetic operators, logical operator, relational operator, bitwise operator, and last one is assignment operator. We will discuss one by one in detail. Next is ternary operator. So the other name for ternary operator is conditional operator. So coming to unary operator, so these are the different operators which are applied on single operands, or which operate on single operands or variables, you can say. First one is minus. So this minus and the minus, there is also another minus which comes in binary operator. Both are different. So here this minus is used to, this minus sign is used to change the sign of the variable. So this minus sign is used to change the sign of the variable. So for example, x is equal to 5. Now if you apply this minus sign, so x, now value of x will be minus 5. So just in order to change the, or in other way you can write it as if you assign y is equal to minus x, then here x value, which is 5, now y value is minus 5. So in this way, you can make use of this minus unary operator, that is minus operator. Next is increment and decrement operator, address of operator, and then size of operator. First one, minus. So unary minus is used for indicating or changing the algebraic sign of a variable. So for example, here we have two variables which are assigned as, one is, so both are of integer type. So data type of variables, there are different types of variables, there are different types of data types. So data types we'll discuss later on. So here we are using integer data types. X is equal to minus 50 and y is equal to minus x. So x is equal to minus 50, y is equal to minus x means already we have x is equal to minus 50. So unary minus sign will be operated on this operand. Now the value of y is equal to 50. So in this way unary minus operator works. Next is increment operator and decrement operator. So increment and decrement, again we have two types, in pre-increment and post-increment. Even for decrement also same, we have pre-increment and post-increment. So next is, so how does these two operators behave? So let us see with the help of example. So increment operator means it will add 1 to its operand. Suppose, so this is same as x is equal to x plus 1. So x plus plus or plus plus x. Both of them it is same as x is equal to x plus 1. That means we have to increment the value of x by 1. Next, x minus minus or minus minus x is same as x is equal to x minus 1. So that is what written here. The operator minus minus subtracts 1 from its operand. X is equal to x plus 1. We can write it as x plus plus or plus plus x. So when this operator comes after the variable, it is called as post increment, and when this operator comes before the operand, then it is pre increment. Now similarly, decrement operator also, x is equal to x minus 1. We can write it as x minus minus or minus minus x. So this is post decrement and this one is pre decrement. So there is a difference between the two, but pre increment and post increment. So for that, in order to understand that, we have a small example here. One sample program is available here. So we have taken two variables. So this is also an operator, special operator called as comma operator, which is used to separate two variables of the same data type. So that we'll discuss in the, this operator is there in special characters. So there we'll discuss in detail. So here we have two variables p and q, both of them belonging to the same data type, that is integer. What we have done is we have assigned the value of 10 to p. So p is equal to 10 now. P is equal to 10. Now q is equal to plus plus p. So this is pre-increment operator. So this is pre-increment operator applied on p. Now initial value of p is, next after that we have written two printf statements. So in one printf, p value is printed, and in the other printf statement, q value is printed. Now let us see what is the output of these two. So pre-increment operator, what it happens is, first the value of p will be incremented. So in pre-increment operator, the value of p is incremented by 1, then it is assigned to q. So now initially the value of p is 10. Now after incrementing, when we have p is equal to p plus 1, so value of p will be, after plus plus, p is equal to 11. So this value will be assigned to q now. So q will also be 11, and after incrementing, p will also be 11. So therefore the output of this will be 11 and 11. Now let us see post increment operator. Same program. So here we have implemented post increment operator. We have used post increment operator. So here also we have assigned p is equal to 10, and we have written two printf statements after this, after applying the increment operator, that is post increment operator. So in one line p is printed and the other line q is printed. Now here what happens is, this is post increment operator. So now whatever the value of p is there, so now p is equal to 10. So that 10 is assigned to, so this 10 is assigned to q now, and then after that the value of p will be incremented by 1. So p will be equal to 11. So when you go for printing the values of p and q, so p will be 11 and q will be 10. So that is the difference between pre-increment and post-increment operator. Next is address of operator. So address of operator, this operator we use in scanf functions. So this prints the address of the variable in the memory. Next is size of operator. So this size of operator, it gives the bytes occupied by a variable. So this size is given in terms of bytes required in memory to store the value. So in order to store a particular variable, how many bytes are required in the memory? So that is determined, or that value is given by the size of operator. So number of bytes, so which is occupied by a variable, that depends upon the data type. So we have different data types like integer, float, character, etc. So all this we will discuss in the coming video lectures. Next is binary operators. So binary operators are the operators which require two operands. So here two operands or variables are required. So in this, so these are the different types in binary operators. First one is arithmetic operators. Next is logical operators, relational operators, bitwise operators, and the last one is assignment operators. So first one, let us see arithmetic operators. So from the name itself, we can say that arithmetic operators imply the operators which are used to perform mathematical calculations. So these can be addition, subtraction, multiplication, division, and modulus in C. So first one, so operator symbol is for doing addition is plus, and operator symbol for doing subtraction is minus. So multiplication is this asterisk, and for division it is slash, and for modulus it is percentage symbol. So let us understand this with the help of example. So we know this. So in arithmetic operator, they perform arithmetic operations. So for example, if there are two variables with values, if a is equal to 2 and b is also equal to 2, and if we do a plus b operation, the output of this will be 4. Next is similarly, if a is equal to, so we can, so in order to get this as the output, in order to subtract these two values, so we have a minus b. So here if a is equal to 5 here and b is equal to 3 here, so 5 minus 3, 2 will be the answer. Now similarly, you can perform multiplication. So 2 into 5 is 10. So 10 divided by 2 is 5, and here this modulus symbol, it will return the, so 10 divided by 2 is 5. This is the quotient, and this one is the remainder you get. So 11 divided by 3 is. Next is logical operators. So logical operators are used to perform logical operations. So it gives logical relationship between two expressions. So after checking the condition, so logical operators, it will evaluate, the result will be either true or false. If the expression value is true, if the expression is true, is evaluated to true, then the value will be 1. If the expression is evaluated to false, then the value will be 0. That means the output of this logical operation will be, it can be either 1 or 0. So operands could be constants, variables, or expressions. So logical AND. So in this logical operators, mainly we have three operators: logical AND, logical OR, and the last one is logical NOT operator. Logical AND is denoted by this symbol. Logical OR is denoted by this, and logical NOT is this one. This is logical AND. So logical AND. So it will return if there are two expressions. So 0, 0 will be evaluated to 0, 0, 1 will be 0, 1 and 0 will be 0, 1, 1 will be 1. Similarly, so this is for logical AND. for logical OR, so you can write the table as, so 0 0 means, so output will be 0, so this is the output. If we have two inputs, so these are the inputs and this one is the output. If we have 0 1, the output will be 1, 1 0 means 1, 1 1 is 1. Similarly, for logical NOT operator, if the input is 0, the output is 1. If input is 1, the output will be 0. Now let us see with the help of an example. So logical AND operator. So it performs logical operations. So for example, if there are two expressions here. So 5 greater than 3 and 5 less than 10. 5 is greater than 3, it returns true. So true means it will give 1, and 5 is less than 10. 5 is less than 10 means it will return, this also will return true. So output will be 1 and 1 is equal to, as compared, so last we have written here 1 and 1 will be equal to 1. So hence the return value will be 1. Next is logical OR operator. So logical OR operator, so it will evaluate the two expressions, and based on that you will get either it will either return 1 or 0. So 8 is greater than 5, that means it is true. Next OR, and then after that 8 is less than true, that is false. So therefore the resultant will be 1 or 0 means it will be 1. Next, logical NOT operator. So if we have a variable value c is equal to 5, then with this c is equal to 5, so this is double equal to, that means we are comparing these two. 5 is equal to 5 means that is true, but when you apply NOT operator to this expression, so this is true. So output of this will be 1, but the output of this will be 0. That's why you get 0 here. So in this way, logical operators perform. Next is relational operators. So here also, relational operators, they provide relationship between two expressions. So it will return either true or false. If it is true, then we get 1. If it is false, we get 0. So these are the different operators which are available in relational operators. So this is greater than, less than or equal to, greater than or equal to, this is equal to, and this one is not equal to. So consider an example here. Suppose we have an expression. So this is an expression, it has relational operator here. So relational operator, what we are doing, we are comparing these two values. 5 is greater than 4. 5 is greater than 4, it evaluates to true. So this is true means the value will be 1. So that is what 1 here. Now 10 is less than 9. This is false. So therefore it will return 0. Next, 10 is less than or equal to 10. Either one of the condition is satisfied, therefore it will return true, that is 1. Next, 11 is greater than 5 or equal to is also there. So 11 is greater than 5, so it will return true, that is 1. Next, 2 is equal to 3. 2 is not equal to 3, so therefore it will return false. So false means 0. Next, 3 is not equal to 3, but 3 is equal to 3, so therefore it will return 0. So in this way, relational operators perform. Next is bitwise operator. So in bitwise operators, we have bitwise AND, bitwise OR, bitwise exclusive OR, bitwise ones complement, bitwise right shift operator, bitwise left shift operator. So we'll see one by one. So in computer, so decimal numbers are converted to binary form. So bitwise operators, we have bitwise AND, bitwise OR, and then bitwise exclusive OR, and then bitwise complement operator. So bitwise AND operator, if the two bits are 0, then the output will be 0. If the two bits are, if one of the bit is 0 and the other bit is 1, then the resultant bit will be 0. So this behaves same as logical AND operator only. So 1 and 0 will be 0, 1, 1 will be 1. Next, this is the table for OR operator. So if we have two bits where one of the bit is 0 and the other bit is 0, so output bit will be 0. If we have 0 and 1, the resultant will be 1. If we have 1 and 0, the resultant will be 1. If we have 1 and 1, the resultant will be 1. Similarly for exclusive OR, So exclusive OR and this OR behaves the same except for this last value. So in this case, if both the bits are 0, if both the bits are same, then the output will be 0. Else, the output will be 1. Now here, table for bitwise complement operator. So if the input bit is 0, the output will be 1. If input is 1, the output will be 0. So let us understand this different types of operators with the help of one example. Suppose there are two variables of type integer. Suppose a is equal to 5 and we have one more variable b is equal to 6. So both are belonging to integer type. So in order to perform bitwise operators, first we need to convert this two values to binary form. So binary representation of 5 is, 5 you can represent it as 1 0 1. Next to binary representation of 6 is 1 1 0. Now in order to perform, so this is how you can perform bitwise AND operation. So as we know that 1 byte is equal to 8 bits. So therefore we have taken 8 bits. So 1 0, the binary representation of 5 is 1 0 1, remaining all the places are filled with 0. Similarly, the binary representation of 6 is 1 1 0 and remaining all the digits are filled with 0. So if you perform bitwise AND operation for these two numbers, then 1 and 0 is 0. 0 and 1 is 0, 1 and 1 is 1. So again you convert it to decimal form. So in order to convert this to decimal form, so you can write it as, so this is 2 power 0 plus 2 power 1 plus 2 power 2. So this will be evaluated to, so 1 into 2 power 2, this is 0 into 2 power 1 and this one is 0 into 2 power 0. So 2 power 2 is 4. So answer is equal to 4. So in this way you can perform bitwise AND operation. Similarly, to perform bitwise OR operation, 1 0 1 1 1 0. So 1 1 is equal to, so bitwise OR operation, if you have 1 and 0, output will be 1, 0 and 1 1, 1 1 is 1. So convert it to decimal form. So decimal form is 2 power 0, 2 power 1, 2 power 2. So add all these two, you have to multiply these two. So 2 power 0 into 1 is 1. 2 power 1 into 1 is 2. 2 power 2 into 1 is 2 power 2. This is equal to 2 to the 4, 4, 5, 6, 7. So in this way, this is bitwise OR operation. Next, similarly, we can perform bitwise exclusive OR operation. So in order to perform, so this is the operator, bitwise exclusive OR operation. Similarly, you can do here 1 0 1 1 1 0. So this is 5 and this one is 6. So when both, here you can see from the table. So for table for exclusive OR, when both the bits are same, you will get 0. So when both the bits are same, you get 0. Remaining all is 1. So this is 2 power 0. That means 1. And plus, and this is equal to 2 plus 1, 3. So this is bitwise exclusive OR operation. Similarly, to perform, next to the other one is bitwise ones complement operator. So bitwise ones complement operator. So when you apply this ones complement operator on 5, the output is equal to -6. Now the binary representation of 6 is, as we have seen here, it is 1 0 1. Then apply bitwise. So from bitwise complement operator, if the bit is 0, the output is 1. Then apply bitwise complement operator. So output will be 1, 0, 0. This is 0, 1, 2, 3, 4, 5, 6 and 7. So 1 byte is equal to 8 bits. So therefore, so remaining all the places, so 1 will correspond to, 0 will correspond to 1. So 1 will change to 0, 1 will change to 0. This 0 will change to 1. This is 1, this is 1, this is 1 and this is 1. Then after that, so when you apply bitwise 1's complement to 5, the answer is 6. So how minus 6 is stored in the computer? So that we'll see here. So after, then take 2's complement. Take 2's complement means you have to add 1. This is 0, this is 0, 1. Remaining all the places will be 1, 1, 1. So this will be equal to minus 6. So in this way, when you apply bitwise complement operator, so you will get minus 6. So this is a process how minus 6 is stored in the memory. Next is bitwise left shift operator. So this indicates the number of bits a particular variable or value is shifted. So here 5 left shift 1 means 5 is shifted to the left by 1 bit. So one representation of 5 is 101. When it is shifted to the left by 1 bit means it will be 1011. So decimal representation of this will be 2 power 1 plus 2 power 3. So this is equal to 8 plus 2. So that is equal to 10. Next, similarly, bitwise right shift operation. So in order to perform right shift operation, so this indicates number of bits this particular variable is shifted. So 5 is shifted to the right by 1 bit. So resultant will be equal to 1. Next is assignment operator. So it will assign a value to a variable. So for example, int x is equal to 5. So here 5 is assigned to x and this is carried out by the operator equal to. The equal sign is used for assignment and hence the name assignment operator. So there are other assignment operators also like plus equal to, minus equal to, then multiply equal to, equal to. So these are also the different operators. So these are called as compound operators. Compound operators. So what they do is, suppose we have a is equal to 5. So if we write a plus is equal to 10, what it means is a is equal to a plus 10. So this expression final answer will be 5 plus 10 which is equal to 15. So in this way, similarly a minus is equal to 10 means a is equal to a minus 10. So that is 5 minus 10 which is equal to minus 5. Similarly, these also. Next is ternary operator. So ternary operator is also called as conditional operator. Conditional operator, it contains condition which are followed by two statements or expressions. So these are the two expressions. So ternary, it is called ternary operator because it takes three operands. So there are three operands involved. First one is condition, second one is expression 1 and then we have expression 2. So therefore it is called as ternary operator. So syntax to apply this ternary operator is condition followed by question mark and then expression 1 followed by colon and then we have expression 2. Then last we have semicolon. So if the condition is true, so whatever the condition is given, so this will be a logical here you will have an expression which will involve logical operators. So this is the condition. This condition it will return either true or false. If it is true, expression 1 will be evaluated. If the condition is false, expression 2 will be evaluated. So for example, consider this example 2 is equal to 3. So that means, so this is false. This is false means after the question mark, this is expression 1 and this one is expression 2. So if it is true means first one will be evaluated. If it is false means the second one will be evaluated. So therefore the output will be 5. So in this way ternary operator works. So ternary operator, it takes 3 operands: condition, expression 1 and expression 2. If the condition is true, then expression 1 will be evaluated. If the condition is false, expression 2 will be evaluated. Next is special characters. So in C tokens, we have special characters also. So already in the basic structure, while discussing the basic structure of C programming, so there we have discussed some of the special characters like curly braces. So curly braces are used. So these are used as opening and closing of the code. So these are used for opening and closing of the code. It is used in opening and closing of the loops also. Next is simple brackets you have. So these brackets we use for function declaration as well as function calling. For example, printf is a predefined function. So here you can see that we are using simple brackets here. Next is square brackets. So opening and closing brackets represent the single and multi-dimensional subscripts. After that we have some more special characters like comma, then preprocessor and then asterisk. So comma is used to separate more than one statement, or you can say that separating function parameters in a function call. So this we'll discuss in detail when we will discuss about functions. So it also separates the variable when printing the value of more than one variable using single printf statement. Next to preprocessor. So it is used for preprocessor directive. So it basically indicates that we are using the header file. Next is asterisk symbol. So this symbol is used for multiplication. Apart from that, it is also used to represent pointers also. So last one in C tokens is strings. So strings in C are nothing but array of characters having null character at the end of the string. So this null character denotes the end of the string. So anything which is indicated in double quotes, so that becomes a string. So strings in C are enclosed within double quotes. Size of a string is the number of characters that the string contains. So we'll discuss about strings in detail in the coming lectures. So in the coming video lectures, we'll discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.